If we take the following expression, 3 plus 4 multiplied by 5, what is the final result of this expression? Well, if we add 3 and 4, that's going to be 7. And then if we multiply 7 into 5, we get 35. But what if I were to multiply 4 into 5 first? Well, then I get 20. And then if I add 3 to that, I get 23. These are two completely different answers. Well, which one is correct? Well, we know that the correct answer is the one that follows a ruled set known as PEMDAS. It can also be written as PEMDAS, and we'll see that that actually is the case. It doesn't matter if I do multiplication or division or multiplication first. In fact, you're going to notice that it doesn't even matter which order I do addition or subtraction. But it is easy for us to remember how to do the order of operations if we remember an acronym that gives it to us in this way. And what does PEMDAS actually mean? Well, it's basically the highest priority down to the lowest priority, starting from left to right. So there's an order of operations in which these operators get resolved first. So the first thing, the P, refers to parentheses. So anything that's in a parentheses, or they could even be square brackets. The next one refers to exponents. So something like 4 squared, or something maybe like 3 plus x squared. These would get resolved first. Multiplication and division gets resolved next, and addition and then subtractions get resolved next. Multiplication and division need to happen from left to right, and addition and subtraction also need to happen from left to right. So PEMDAS, however you want to do it, I think I'm going to go from here and call it PEMDAS. It's very important that we follow an order of operations because everyone needs to come up with the same consistent answer. I need everyone to come back to me and tell me that this result or this expression is 23. I do not need somebody to come to me and say, no, that expression actually is 35, because that's not correct. It doesn't follow. Now, one thing we could probably do from here is maybe just have a small refresher course about what it means to be an exponent. So let's take, for example, 4 raised to the third power. An exponent has a base. In this case, that base is 4. And it has a power, and in this case, that power is 3. And what an exponent does is it basically says this base is going to be multiplied 3 times. So 4 to the third power is going to be 4 times 4 times 4. I'm taking the value 4 and I'm multiplying it 3 times to get the value 64. It would be the same if I had 5 to the 5th power. That would be equal to 5 times 5 times 5 times 5 times 5. If I'm not mistaken, this might be somewhere along the lines of 3,164. 3,125. I have it written down. So this is how exponents work. And they're quite simple. And even if I were to have something like x plus 3 times 2, it's the same idea. This is simply just x plus 3 times x plus 3. It'd be the same if I had 4x squared. That's the same as saying 4x times 4x. And we're going to learn how we can multiply these out. This is a little bit more advanced math. We're not going to worry too much about this kind of math. We're going to concentrate more on just order of operations, and that's it. So going to the worksheet here, let's look at what the simplified form of 5 times 7 minus 4 squared divided by 2 is going to be. So we solve this using the order of operations. So we perform any operation inside grouping symbols such as parentheses and brackets. Do you see any parentheses or brackets in this expression? I don't see any at all, so we can skip the parentheses part. Now we simplify powers. Well, I do see an exponent here. That exponent is 4 squared. And so I'm going to simplify that by saying 5 times 7 minus 16 divided by 2. I will now take multiply and divide in order from left to right. So I have 5 times 7. I will resolve that now, 35. I'm not dealing with subtractions just yet. I will now divide 16 divided by 2. I will resolve that. That will be 8. And now that I have no more multiplication or division, I will now add and subtract in order from left to right. Well, I've only got one operation left. It's 35 minus 8. And so that's actually going to be, I believe that's 27 is going to be the final answer for that value. Now let's not forget about algebraic expressions. And when we have an algebraic expression, we now need to be told explicitly what my a value or what my variable values are going to be, any of the unknowns that are in my expression. Because if I want to apply an order of operations, I need to know what the values are. And if I know what the values are, then I can start applying an order of operations. But if I, have unknowns in here, then I can't really simplify this. I have no idea what to do. And so whenever you're told to operate to do some simplifying using PEMDAS, and you have unknowns, you're going to be told what those unknowns are, or at least you're going to have to maybe solve for them, and you'll be given at least a half a chance to be able to solve for these unknowns. So let's look at a few of these examples here. The value of 3b minus a squared. Now, what is this value if we are to assume that a is 3 and b is equal to 4? Well, we know that if a is 3, then a squared must be equal to 3 squared, and this must be equal to 9. If b is equal to 4, then we know that 3 times b must be equal to 3 times 4, and that's of course equal to 7, or 12, I mean. But let's just write this out, this 3 squared and this 3 times 4 without really simplifying them just yet. We would have 3 times 4 minus 3 squared. Well, now which one do we do first? We obviously need to look at if there's any parentheses, which there are not. Then we look for exponents, which we do have. We have an exponent right here. That's going to be 9. Now, this particular example decides to combine a few, and they get away with it. In some cases, in most cases, you will learn that you can get away with doing 2 things at once. It's perfectly fine in this case. They also multiply 3 into 4, and that's going to be equal to 12. I now take the final operation here, which is a subtraction, 12 minus 9, and that's going to be equal to 3. So when a is equal to 3, and b is equal to 4, then the algebraic expression, I'm going to keep using these terms so that they get, kind of hardwired into your mind. 3 times b minus a squared is equal to 3. Only when a is 3 and b is 4 in this case. All right, last, let's look at a word problem. This is going to be our first real-world word problem here. So we have, let's read this. The shipping cost for an order at an online store is 1/10 the cost of the items you order. What is an expression for the total cost of a given order? And what are the total costs for orders of $43, $79, $95, and $103? Again, we need to know what my independent value is, and we need to know what my dependent value is. And in some cases, it's just easy to come up with 2 columns of data. And so the independent value, remember again, that's the one that we control. That's a user-dependent value. What do I control in this particular word problem? Well, it seems to me that I control what the total cost of an order is going to be, because that is going to be what I am going to give to this shipping cost. In order to determine what my shipping cost is, I need to know what the cost of my items are. And so if I know that the cost of my items is $43, and I was told that 1/10 of that is shipping, well then I will take 43, I will multiply that by 1/10, and what I get is I get 43 divided by 10, and we know that this is equal to 4.3. That's my shipping cost. I can do the same thing with 79. I take 79 and I multiply that again by 1/10, and I will rewrite that as 79 divided by 10, and that's going to be equal to 7.9. Now, what exactly have I done? What is my independent value? Well, my independent value is these values. I'm plugging in some random number, 43, 79, it doesn't matter. What is my dependent value? Well, I can't get 4.3 unless I take the independent value, 43, and I multiply it by 1/10. This is my dependent value. And this is the expression that resolves this. Remember when I said 5 is equal to 5? Well, 43 times 1 divided by 10 is equal to 4.3. And we're not going to write 4.3 as my answer. They're asking me what is an expression that gave me the answer 4.3. Well, that expression was 43 times 1/10. Now, what you do to give the answer to this problem, what is the algebraic expression? Remember, an algebraic expression needs to have a variable in it. My unknown can be my independent value. That's what I'm just plugging values in. So it's going to be x times 1/10. And I could rewrite this actually as x over 10 if I wanted to. This is my algebraic expression. If I plug in 43 for x, I get 4.3. If I plug in 79 for x, I get 7.9. If I plug in 95, I get 9.5. If I plug in 103, I get 10.3. So as you can see, this same word problem was solved in exactly the same way that we solved the last one from lesson 1. I needed to understand what is my independent value, what is my dependent value, and based on knowing which one is which, generating an expression using my independent value that will create the dependent values from that independent value. I know it's a lot. It's kind of hard to follow. It's new. And word problems tend to be very new for students, especially when they get into algebra. It's a problem that we have to solve. It's one of those things that I always try to figure out new ways of teaching it. But eventually, a lot of it's going to have to be you practicing this over and over again. And I'll have plenty of practice for you guys when it comes to this, so that you guys can get used to this idea of how do I get an independent value? How do I get my dependent value? And how can I take that dependent value and turn it into an expression in terms of the independent variable?